All right, we have f of x defined as the square root of the absolute value of x minus 2. We're asked some statements about this. So we're asked about continuity and differentiability in most cases. If you look through these, continuous but not differentiable, differentiable is not continuous, we have that a limit is not equal to 0, and we have a vertical asymptote. So real quick, I can cross off vertical asymptote because a vertical asymptote happens when a denominator is 0 and there is no denominator here, right? There's no denominator, so I can cross that one off. Unfortunately, to narrow it down from the others, it's really easier if you can picture this graph. And I get that maybe some of us can't, but that's going to be the best option. So the best option here is to look and think about so if I graphed just the square root of x minus 2, right? If I just graphed the square root of x minus 2, it's going to look like a square root that is shifted to the right 2. So it's going to look like this, okay? That's what the square root of x minus 2 would look like. If I then put the absolute value in it, right, what the absolute value is going to do, essentially, is the absolute value means that just like when you plug a 3 in, you'd get root 3 minus 2, which is 1. If you plugged in a 1, you'd get, so now if I introduce the absolute value of this x minus 2 inside here, the 1 is going to behave the same as a 3, because if I do 1 minus 2, I'm still going to get a positive 1 because the absolute value. So basically, this is what the graph's going to look like. It's going to look like you took that square root graph and folded it across this line. Once you see that, you can pretty much pick that it's A, because it is continuous, right? I don't have to lift my pen, but that pointy thing is going to make it not differentiable. If you can see the graph, it's much easier. If you can't see it, you really don't have a lot of great options. The only way to split this up algebraically is basically to say that this thing is a piecewise function. It behaves like this for x values after 2 or equal to 2, and it behaves as the opposite of the inside thing for x values less than 2, and then which again would actually work out because you'd graph this piece as the blue piece, right? And this piece is the black piece, and you could figure it out. But it's much harder to figure it out algebraically. This is much easier if you can figure it out by knowing what the graph looks like. A little bit of algebra and graphing knowledge goes a long way on this test.